Hello, I'm Jane Jean Kiam from the University of the Bundeswehr Munich. Together with my co-authors Pascal and Axel, we investigated on the issue temporal hierarchical task network planning with nested multi-vehicle routing problems. And we compile our findings in a challenge paper for today's workshop. To give an idea on the motivation behind, we first present a typical scenario during a complex rescue mission within a large area, where multiple agents like human first responders, helicopters, and even unmanned ground and area vehicles are involved to explore, search, and carry out rescue tasks at different points of interest. A location of interest groups multiple points of interest together, in which a rescue team of heterogeneous agents operate cooperatively. So temporal hierarchical task network planning has great potential in solving planning problems of such missions. Firstly, because these missions are usually highly structured and have to follow certain procedures and best practices. Secondly, rescue missions are organized in a very hierarchical manner. So decisions are often made at a higher strategic level to more local and more tactical levels. Thirdly, time is an important factor in the planning, not only to manage urgency by imposing temporal constraints, but also to manage resources. However, for temporal HTN planning to be really applicable for such class of planning problems, several challenges have to be first resolved. The first challenge is the consideration of the ability for recursive task decomposition, as can be seen here in this block, where the decomposition of a monitoring task in a location requires that each point of interest be monitored by either a first human responder, an unmanned ground vehicle, or an unmanned aerial vehicle, and depending on the, for example, the accessibility of these points of interest. The decomposition is only considered done when each point of interest is assigned one of the agents. Another challenge that temporal HTN planning faces is the consideration of more complex utility functions. For example, cumulative probabilistic utility functions that take form of a Bellman equation, for example. And in many cases, in multi-vehicle routing problems, we also need to be able to perform multi-objective optimization. Lastly, a challenge that should also be considered is the involvement of multiple agents or action executors. In temporal HTN planning, the decomposition of the high-level tasks must sometimes already consider which agents will eventually execute them, which is not always trivial to know or decide when we are reasoning at a higher task abstraction level. So after doing some research on a previous work, to resolve these challenges, we believe that the first thing to do is to define a theoretical formalism to consider these aspects, followed by defining a syntax to model such class of problems. Next, existing HTN planning system has to be extended to consider the challenges. Last but not least, whatever the development is, the practical framework has to be considered Typically, planning for such missions can be done offline, online with planning and acting, or offline planning and then plan repair during execution. So, and all this depends on the communication infrastructure that can be put in place during the missions. So we have a poster here, and Pascal and I will be very happy if you could pass by and chat with us about the challenges and discuss about previous and future works and some of your ideas. Thank you, and see you later.